In lesson 19, we're going to use the comparison of ratios looking at unit rate and measurement conversions to analyze tables, graphs, and equations. So our first example, the ratio of cups of blue paint and cups of red paint is 1 to 2, which means for every cup of blue paint, there are 2 cups of red paint. In this case, the equation would be red is equal to 2 times blue, or R is equal to 2B. This equation we know is correct because R is the right side. So our equation would be the side, R, equals the value of that side, which would be 2 over 1, which equals 2 times the other side, which would be blue. And where B represents the amount of blue paint and R represents the amount of red paint, make a table of values. Well, lucky enough, 1 and 2 make it to where we can fill out our table of values without having to use the equation. Blue paint is 1, red paint is 2. Blue means we're counting by 1s, 1, 2, 3, 4. Red paint would be counting by 2s, 2, 4, 6, 8. We're done. Now, in order to see, because there will be times that we're going to be having fractions in there, which may make it difficult for you to know how to skip count by, and you want to use your equation. Also, they may ask us a question with a really large number that we can't put on the table because it would take too long to get there, and you want to be able to use the equation to solve it. So below I showed you for each one how the equation would give us that answer. So for the first one, I wrote the original equation over here just once. R equals 2B. For the first one, B equals 1. So I took R equals 2 times 1 equals 2. For the next one, B equals 2. So you took R equals 2 times 2, which is 4. So your red paint was 4 cups. Next one, B equals 3. Plug in your 3 where the B is. R equals 2 times 3, which is 6. Which would mean there are 6 cups of red paint. And lastly, my B equals 4. So I took R equals 2 times 4, because it's B, which gives me 8. R equals 8, which is what I have on my table. Now, the problem below actually has an error in your book, and we're going to make that correction. So looking here, Miss Sipple is a librarian who really enjoys reading. She can read 3/4 of a book in one day. So that's my ratio. 3/4 of a book to 1. The relationship can be represented in the equation day equals 3/4 books. This is incorrect. And I'm going to show you why. So down here, we're going to go ahead and just write the ratio that they gave us. And the ratio is number of books 3/4, and it's 1 day. So let's write the equation. Starting with days, because that's what they started with, we're going to say days equals, well, what's my value of days? It would be 1 over 3/4. Now, we can't have a fraction as the denominator, so we're going to go ahead and solve this. And what you do if your fraction is a denominator, you just flip it over. So that becomes 4 over 3. And what's my other side than days? Books. So my actual equation, which I'll write up here, should be D equals 4/3 books. Now I should be able to solve this correctly. So if I put a 1 in for my books, I would say D equals 4/3 times 1, which would equal days is 4/3. That would be 1 book, 4/3 days, which is 1 1/3 days. If you look, I just counted by 2/4, which gave me 3/4 plus 2/4, plus 1/4 gave me 1. So I'm going to keep going by 1/4. And so this days would be 1 and 1/4, which as an improper fraction, 4 times 1 is 4, plus 1 is 5, so that's 5/4. I'm going to plug it into my equation. I have days equals 4/3 times 5/4. Multiply that out. Days equals 4 times 5 is 20. 3 times 4 is 12. 12 can go into 20 once with a remainder of 8/12. Now, 8 and 12 can be simplified. Both of them can be divided by 4. So my days would equal 1. 8 divided by 4 is 2. 12 divided by 4 is 3. And that would be in 1 2/3 days. She can, Miss Sipple can read 1 1/4 books. Let's go ahead and jump to 2 days and just see how much it changes. So I recognize I'm not skip counting. But I want to show you how this works on your equations. We have my days equals 4/3 times my number of books, which was 2. This is a 2 over 1. So this is actually 4/3 times 2 over 1. 4 times 2 is 8. 3 times 1 is 3. Gives me 8/3. So my days is equal to 2. 8 divided by 3 would give me 2. Remainder 2. So that'd be 2 and 2/3. And just to double check yourself, see if this is true, this would be 1 times 2 gives me 2, which means I should take 4/3 times 2 and get this answer. So 4/3 times 2, I'm just going to do it up here where I have some extra room. 4/3 times 2 gave me 8/3, which is what I found down here, 8/3, which is simplified to 2 and 2/3. So this equation is correct. Going on one more example, because it's going to give us a bit more to work with the exercises. So here's your first one. Brian and Shanice are both training for a bike race and want to compare who rides his or her bike at a faster rate. Both bikers use apps on their phones to record the time and distance of their bike rides. Brian's app keeps his route on a table, where Shanice's app represents hers on a graph. The information is shown below. We have 2 questions it's asking. First question, at what rate does each biker travel? Explain how you arrived at your answer. So remember, a rate is per 1. So what I need to do is find out per 1. I'm going to go over here to my table, making a ratio table from the table they have. And what they gave me was 3 hours. This is 0, 0, not helpful for a rate, but 3 to 75 is, but hours to miles. So I want to know in 1 hour how long will it take them. So what I'm doing is I'm going from a 3 to a 1. I'm making a equivalent ratio, 3 to 1. Now, I could take 1 divided by 3, which is 1/3. 1/3 times 75 is my answer. You could do that. Or you could take 1, what did I do to 3 to get a 1? Well, I divided by 3. So 3 divided by 3 is 1. 75 divided by 3 is 25. So Brian's rate is 25 miles per hour. And that's because with 1 hour, it's 25. Now, showing you what I was saying, you could have done by dividing and multiplying the way we had been doing it before. You have hours and miles. I would take, going to a 1, I'd take 1 divided by 3, which is 1/3. Remember, we can write division as a fraction. And I'd take 75 times 1/3. The way that would look is 75 times 1 over 3. 75 times 1 gives me 75. 1 times 3 would give me a 3 as my denominator. 75 divided by 3 is 25, giving me Brian's rate of 25 miles per hour. Now, Shanice's is quite a bit easier because they give us our hours. Our rate is here with the 1 hour. So all I do is go up on her 1. It's about halfway between 10 and 20. Halfway between 10 and 20 is a 15. So Shanice's rate is 15 miles per hour. Now, second question. Shanice wants to win the bike race. Make a new graph to show the speed Shanice would have to ride her bike in order to beat Brian. Well, Brian is 25 miles per hour, so I have to be bigger than 25 miles per hour. What I'm going to do is the simplest one and say she would do 26 miles per hour. Now, you could do 30, 40, 50, something bigger than 25. And again, I'm just going with the simplest one. So I have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to label it number of hours. My other side is going to be number of miles. And like I said, I'm actually going to say that she goes 26 miles per hour. If you feel like it'd be easier to count by 30 miles per hour, you could do that as well. So this is 26. That would be a 52. 78 plus 26 would be 100 and something. That's 14. Carrier 1, 104. Plus 26 would be 130. Plus 26 is 156. Plus 26 would be 182. Plus 26 would be 108. 208, I'm sorry. We'll go ahead and stop there. So I have a 1 and 26, 2 and 52, 3 and 78, 4 and 104, 5 and 130, 6, 156, 7, 182, 8. And then I'd have my line going straight through, which means I know all my other points would fall right there on the line. And we should have all of our numbers filled in. There you go. And this would be an example of her rate. And I would even maybe just write the rate also to kind of add another definition for someone looking at it so that it wouldn't just be on the table. We could actually say this table represents 26 miles per hour. And that would be all you need. Go ahead and do number 2, A and B. Have me check it before you move on to your checkpoint.